Welcome to part 2 of the Introduction to Unit Circle. What we learned in part 1 was that the coordinates of the point where the terminal side of the angle, in this case we'll call it theta, meets the circumference, is equal to the cosine of theta for x and the sine of theta for y. In other words, the side opposite angle theta is equal to the sine of theta, and the side adjacent is equal to the cosine of theta. Let's do an example and see what we're talking about. So what I've done here is drawn an angle of 120 degrees that would go from here, and this is our angle theta, which is 120 degrees. And what we've learned is that the coordinates of that point right there will be the cosine of theta, or the cosine of 120, and the sine of theta, or the sine of 120. So the way we figure that out is we drop the perpendicular and we try to figure out the reference angle, and we know that if we have 120 degrees, 60 more will give us 180. So this angle in here has got to be 60 degrees. And we need to simply figure out what is the cosine of 60 degrees in the second quadrant. Now we know the cosine of 60 degrees is a half. But if you notice in the second quadrant, the x value is always negative. And therefore, we have the cosine as negative a half. So therefore, what we just figured out was that the cosine of 120 degrees is equal to negative 0.5. If we want to find the sine of 120 degrees, we just think about what is the sine of 60 in the second quadrant. Well, we know that the sine of 60 is the square root of 3 over 2 in our unit circle. And remember, this is a unit circle, so all the radii are 1. And in the second quadrant, the sine of 60 is positive, and therefore we have positive the square root of 3 over 2. And that tells us that the sine of 120 degrees is equal to the square root of 3 over 2. So this is where the unit circle is very valuable to us. And let me just fix that up. We don't want to mess it up too much. So we'll just put negative 0.5. So by using the unit circle, we have now figured out the cosine of 120 degrees, which is in the second quadrant, must be negative, because the x value is negative in the second quadrant, and it's a half. And that the sine of 120 degrees is positive, because it's in the second quadrant. The y value is positive in the second quadrant, and that's the square root of 3 over 2. The critical part of this is knowing what the reference angle is. In this case, it was 60. Let's do another example. So in this case, theta is going to be 240 degrees. You notice I drew the angle. It ends up in the third quadrant. And you also notice that I drew a perpendicular so that we have a triangle. And we need to figure out the reference angle. And we know that 240 degrees is 180 and 60 more. So in this case, it's 60 again. And notice I'm doing all 60-degree angles in this part 2, just to make it more familiar with you so that we can be consistent. So this reference angle is 60. So in order to find the sine of 240 degrees and to find the cosine of 240 degrees, we need to find the coordinates of this point, because we know that the coordinates of that point are simply the cosine of theta, which is cosine of 240, and the sine of 240. And in order to find that, we use the reference angle, and the cosine of 60, once again, is a half, but in the third quadrant, it's negative. And therefore, the cosine of 240 is equal to the same thing as the cosine of 60, and therefore it's got to be negative 1/2. We want to find the sine of 240 degrees. We look at the sine of 60 degrees in the third quadrant, and we know the sine of 60 degrees is square root of 3 over 2, but in the third quadrant that's negative. So it's got to be negative the square root of 3 over 2. And therefore, we've just found out that the sine of 240 degrees is negative the square root of 3 over 2. Once again, the method is simply to draw your diagram, find the reference angle, and then determine the sine and cosine of the reference angle in the particular quadrant. Let's do one more problem. So in this problem, we have a 300-degree angle, which ends up in the fourth quadrant. And notice once again that 300 plus 60 will give us 360, which is where we got our 60-degree reference angle. And once again, we need to find the cosine and sine, which are the coordinates of this point. The cosine of 300 degrees would be our x value, and the sine of 300 degrees would be our y value. And we notice that the cosine of 300 degrees will be the same thing as the cosine of 60 in the fourth quadrant. Cosine of 60 we know is a half, and in the fourth quadrant that is positive. And therefore, we know that it's 0.5, and that tells us immediately that the cosine of 300 degrees, which is equal to the 0.5, because it's equal to the cosine of 60 in the fourth quadrant. And we know that the sine of 300 degrees will be equal to the sine of 60 in the fourth quadrant. We know that sine of 60 is the square root of 3 over 2, but notice it's negative in the fourth quadrant, because the y value would be negative. So we get negative square root of 3 over 2, and that tells us that the sine of 300 degrees is equal to negative the square root of 3 over 2. Once again, using the fact that we had a unit circle, finding the reference angle, and determining which quadrant we're in will help us find the sine and cosine of our theta, in this case 300 degrees. Okay, now it's your turn. So what we wanted you to do is take a unit circle, and we want you to draw a 30-degree angle, a 150-degree angle, a 210-degree angle, a 330-degree angle, and we want you to find the exact values for the sine and cosine of 30, the sine and cosine of 150, the sine and cosine of 210, and sine and cosine of 330, and that's what we mean by completing the unit circle below. You might find it easier to draw 4 different unit circles and do each of them individually. Good luck, and I'll see you again next time.